Hey. There you are. I'm back again like I never left. What's up? This time I'm back again with a Python exercise in Codewars called swapping cards. There is another simulated game in Codewars. Codewars is good for that kind of stuff. Alrighty. Two players draw a pair of numbered cards so that both players can form a two-digit number. Remember that, two-digit number. A winner can be decided if one player's number is larger than the other player's. So you get two digits, your two digits, the other player's two digits. Which one's larger? That's the winner. However, there is a rule where a player can swap any one of their cards with another one of the other player's cards in a gamble to get a higher number. Note that it is illegal to swap the order of your own cards. You can only swap with the other player's cards. This means that if you draw a 1 and then a 9, you cannot swap them to get a 91. Nope, you cannot. So we're going to assume the role of a player called Paul in here, and we're going to use his strategy to play the game. Paul's strategy is to always swap his lowest number with the opponent's tens digit. Return whether this results in Paul winning the round. So Paul's going to do this strategy no matter what. He's going to take his lowest number and swap with the opponent's tens digit every single time, whether he's winning initially or not. Kind of a foolish strategy, but those are the rules we're playing with Paul. And we're going to assume Paul, so Paul's going to be N1, and then the opponent's going to be N2. The inputs to this function are going to be two-digit integers. First two-digit integer is going to be N1. Second two-digit integer is going to be N2. And we're going to be playing as Paul and doing his strategy, fulfilling his stuff, whatever the hell that means. Let's look at an example. 4179. 41 is Paul. So that's the one we're playing. So Paul's strategy is to swap his lowest number with the opponent's tens digit. So you see this, Paul's lowest number is a 1. The opponent's tens digit is a 7. That's going to result in this one right here, 4719. Because the 1 and the 7 get swapped. Paul has a 47. Opponent has a 19. Paul wins. There you go. So that's how you do it. Let's look at one more. 41 and 19. Find the minimum of Paul's. Paul's is, the minimum is 1. The opponent's tens digit is 9. So this becomes 49, 18, because the 9 and the 1 get swapped. I know this doesn't look very good, but good enough to understand. 49 beats 18. Paul wins again. Paul's killing it. But that's the strategy. You look at Paul's, you get the minimum value, then you swap it with the opponent's tens digit. That's the general strategy here. Another little rule here is that if both of Paul's digits are the same, you swap Paul's tens digit with the opponent's tens digit. So, like something like this. This would be Paul's, this is the opponent. You take Paul's tens digit, and it really doesn't matter because they're both the same, but you take Paul's tens digit and swap it with the opponent's, and that's going to give you, 3776, and then Paul would lose that one. That would be a big fat loser, as the sports junkies say. Anyway, that's that. And with those rules, we're going to slide this into the editor interface, or the editing interface, and let's get it. Let's get it to go, cousin. A lot of damn rules with this one, right? Good grief. That's what programming is, a hell of a lot of rules. I'm going to take a slightly different approach here, and I'm just going to put the code in here and break it down for y'all real quick instead of doing all that dang typing. My fingers is hurting. Not really. Let's move this down. All right, here's your breakdown, folks. N1, N2. These are going to be two-digit integers. N1 is going to be Paul's, so that is going to be our focus. N1 is us, homie. Okay. And I create variables for Paul and the opponent here, of course, to differentiate them. What I do with each of these two-digit numbers is I first will take them and convert them to strings and then to a list, and then there'll be a list of strings, because I want to separate the digits and isolate them so that I can then compare them. That's what I want to do. So then I go down here and I make another modification where I use list comprehension to take each of those numeric strings and turn them into integers. So at the conclusion of this block here, I'm going to have two lists of numeric strings. Sorry. I'm going to have two lists of integers so that I can compare the values. That's what I want. Paul is going to have his two digits integers. Op is going to have two integer digits. Getting tongue-tied here today. All right, line 10. Because of Paul's strategy, I want to get the minimum value in Paul's set of cards or set of integers. So I'm going to use min to get the minimum value of the two. Then I'm going to get the index of that minimum value. I'm going to put that index into Paul min, so that I know the index, because the index is going to be useful when I do the swapping, which is what I'm about to do. Now here we do the swapping. And it's based on a conditional. If I compare Paul's first digit to the second digit, and if they're not the same, meaning if he's got two different numbers, then I do this one, this kind of swap. If they are the same, I do a different swap. So let's look at the first swap. The first swap is going to swap Paul's minimum value with the opponent's tens digit. The opponent's tens digit is denoted by index 0, because index 0 will be the first digit of the two, thus being the tens, because there's two digits in both of these. First index or first element's going to be the tens. And this is Python swapping notation, and it's really cool that Python offers this so that I don't have to do the classic swapping algorithm or some other swapping mechanism. This is very convenient syntax where you really put on the left side, you put the values before, and on the right side, you put what you want to change them to, basically. And how this ends up being is the opponent's tens is going to go where Paul's minimum is, and then Paul's minimum is going to go into the opponent's tens. You're really just swapping these two values. So what you do is you put the two values in order, and then you reverse the order on the right side, and it'll swap the values. Pretty neat. And that's all there really is to say. And then in the else, what you're going to do is, the else condition is if Paul's two digits are the same. If Paul's two digits are the same, you're going to swap Paul's tens with the opponent's tens. Like I said before, index 0 is the tens place. So We take Paul's, swap it with the opponent, and the opponent's that swap it with Paul's, Paul swaps with the opponent's. You get all that? Good, good. All right. Once the swapping is done, here's what you do. Once the swapping is done, I'm going to loop through the list of integers for Paul, convert each integer to a string, then join that string into a string, then convert it to an integer. And I do this for Paul and the opponent because what I want to do is get an integer result. I want to take the list of integers and convert it back into a regular 2-digit integer. And that's what's happening here with both of these. Using list comprehension to convert the list of integers to a list of strings. Then I take the list of strings, convert it to a string. Then I convert that to an integer. Heck of a process, but necessary. Once I have two integers, I take the two integers and compare them. Swapping is done, the conversion is done. All that is left to do is to see who is the big fat winner. So here, if Paul's value for his 2-digit number is greater than his opponent's 2-digit number, then return true. Otherwise, the opponent would be greater or equal, I guess, and you return false. And that's it, folks. There is your breakdown, your solution. Let's run it, test it, all that good stuff. And there you have it. Swapping cards, Python, Codewars. There's a lot that went into this one, but it's a pretty good exercise. And I'm sure it could be done simpler. But this is how I did it. I can only give you what I have, so that's what it is. That's it. Talk to y'all later. I'm good and you're good, and I